To begin, it is important to understand what generative AI or Gen AI entails, how it functions, and how to create a Gen AI project on Google Cloud. Imagine you are a marketing manager spending hours creating compelling content and distributing it through multiple channels, both traditional and new media. Or you're a data scientist writing SQL commands to run complex queries on various data sources. Or perhaps you're an app developer creating a chatbot in a specific field like healthcare. Well, generative AI can be your new go-to friend for all of these tasks. Generative AI is transforming how we interact with technology. So what is generative AI? It is a type of artificial intelligence that generates content for you. What kind of content? Well, the generated content can be multimodal, including text, code, images, speech, video, and even 3D. When given a prompt or a request, generative AI can help you with a variety of tasks, such as launching marketing campaigns, generating code, creating chatbots, extracting information, summarizing documents, and providing virtual assistants. And these are just some examples. Then, how does AI generate new content? It learns from a massive amount of existing content, such as text, image, and video. The process of learning from existing content is called training, which results in the creation of a foundation model. A foundation model is usually a large model in the sense of a significant number of parameters, massive size of training data, and high requirements of computational power. Google has a long history innovating in the area of foundation models and Gen AI technologies. Starting from Transformer in 2017, which lays the foundation for all modern Gen AI applications seen today, to Gemini in 2023, which extends the word general in artificial general intelligence, or AGI, in the sense of handling multimodal processing. At present, the primary foundation models trained by Google include Gemini for multimodal processing, Gemma, a lightweight, open model for language generation, Cody for code generation, and Imagen for image processing. Please note that this list is subject to change as foundation models evolve. Additionally, Gemini has the potential to replace some of these models, as it can process data across multiple modalities. A foundation model can then be used directly to generate content and solve general problems, such as content extraction and document summarization. It can also be trained further with new data sets in your field to solve specific problems, such as financial model generation and healthcare consulting. This results in the creation of a new model that is tailored to your specific needs. This leads to the next point, pre-trained and fine-tuned, meaning to pre-train a foundation model for a general purpose with a large data set, and then fine-tune it for specific aims with a much smaller data set. Imagine training a dog. Often you train your dog basic commands such as sit, come, down, and stay. These commands are normally sufficient for general purposes in everyday life and help your dog become a good canine citizen. However, if you need a special service dog such as a police dog or a guide dog or a hunting dog, you add special trainings. This similar idea applies to pre-trained versus fine-tuned models. For example, a large language model, which is a typical type of generative AI foundation model, is trained for general purposes to solve common language problems such as text classification, question answering, document summarization, and text generation across industries. The models can then be tailored to solve specific problems in different fields such as retail, finance, and entertainment by using relatively small datasets from these fields. Powered by the foundation models like large language models or LLMs, generative AI is driving new opportunities to enhance productivity, save operational costs, and create new values. You might have seen these opportunities from the use case about Coffee on Wheels in Module 1, where you use Gen AI capabilities to automate the marketing campaign, generate customer feedback, and optimize truck route. This sounds exciting. How can you access Gen AI models and create a Gen AI project on Google Cloud? Recall your best friend Vertex AI, which is the end-to-end AI development platform supporting both predictive AI and generative AI? Aside from the capabilities you learned in previous modules for powering the experimentation, training, and implementation of predictive ML models, Vertex AI offers a range of tools for tuning your Gen AI models and developing Gen AI projects, like Vertex AI Studio and Model Garden. Before you dive into these tools, let's walk through the Gen AI workflow on Google Cloud. Input prompt. Via the Vertex AI Studio UI, input a prompt, a natural language request to Gen AI models. Responsible AI and safety measures. The prompt undergoes responsible AI and safety checks, configurable through the UI or code. Foundation models. The screened prompt proceeds to foundation models like Gemini Multimodal or other Gen AI models like Imagen and Cody based on your choices. Model customization. Optionally, customize Gen AI models to fit your data and use cases by further tuning them. Results grounding. Gen AI models return results that undergo grounding and citation checks to prevent hallucinations. Final response. The final response appears on the Vertex AI Studio UI after a final check through responsible AI and safety measures. Let's focus on Vertex AI Studio, the interface to assess Gen AI models, and Model Garden, the repository of Gen AI models, in the following lessons.